Hi, Assalamualaikum warahmatullahi wabarakatuh, and a very good morning, everyone. So, today we are going to continue with our chapter 5, States of Matter. So, last week we have finished chapter 5.1, Gas, and today we are going to continue with subtopic 5.2, Liquid. So there are a few learning outcomes that we are going to cover for today. The first one is we are going to relate the properties of liquid, which are shape, volume, surface tension, viscosity, compressibility, and diffusion. Then we are going to explain the vaporization and condensation process based on the kinetic molecular theory and intermolecular forces. Next, we are going to define what is vapor pressure and boiling point. We are going to explain the difference between boiling point and normal boiling point. And lastly, we are going to explain the relationship between the intermolecular forces and vapor pressure, as well as the relationship between the vapor pressure and the boiling point. Alright, so without further ado, we are going to start now. Okay, um, so ignore this. I have wrongly put today is 22, not 17. Okay, so now we are going to look at the first part of this subtopic, which is the properties of liquid. So you have learned in your lecture session what are the 5 properties of liquid. The first one is the shape and volume. So we're going to look at the first one, shape and volume. So you know that liquid has a definite shape and volume, right? They have a definite shape and volume. What does it mean by that? Means that liquid has the particles in the liquid molecules are arranged closely but not rigidly, which means that the particles are arranged closer than the gas but not too rigid like a solid. Okay, dia dekat tengah-tengah lah kan. Dia tak close, dia tak far apart sangat, dia tak too rigid. So dia closely packed je, tapi dia boleh gerak lagi. Okay. And the molecules head together by an intermolecular forces, but they are able to move freely. They can move quite freely, but dia punya arrangement is not too rigid lah. Dia closely je. Okay. And kenapa Miss kata shape dia and volume dia, shape dia, volume dia definite tapi shape dia not definite? Volume dia definite tapi shape dia not definite. Kenapa? Okay. Sebab when we put this liquid inside the different container, it will take the shape of the container, but the volume will remain the same. Contoh, for example, we have 500 ml of water. Okay, we put inside a gayung, right? It still has a 500 ml volume. It has the definite volume. But when we put inside a beaker, it will become a shape of a beaker lah. And then we will put inside what we call it, jug. And then it will have the shape of a jug. So which means that it does not have a definite shape. Shape dia boleh berubah-ubah mengikut shape of the container. So that's why we say it has a definite volume but not a definite shape. Okay, next we are going to look at the second properties, which is diffusion. So liquid can diffuse, but diffuse between the between the particles lah. Okay, but it can diffuse slower than the gas. Because what? Because gas, they have a very large space between them, right? because gas are arranged far apart from each other, whereas liquid is arranged quite close towards each other, but they still can move freely. So the rate of diffusion for liquid is a bit slower than gas. So okay, reason dia kenapa? Sebab first reason kenapa rate of diffusion liquid slower than gas. First reason sebab molecules closely packed together. Okay, second reason sebab dia ada lower kinetic energy. Sebab apa dia lower kinetic energy? Because it has stronger intermolecular forces between molecules, kan? That's why dia ada lower kinetic energy, sebab dia ada intermolecular forces between molecule. Okay, dia ada stronger intermolecular forces compared to gas. Okay, disebabkan dia closely packed together compared to gas. Okay, that's why diffusion rate dia slower than gas. Okay, next we are going to look at the compressibility. So, compressibility ni apa maksud compressibility? Dia punya kebolehan, dia punya ability to compress. So, liquid, the particles kan the particles kan arrange closely together, kan? So, dia ada a very little empty space between them. So, when they have a very little empty space between them, so liquid are much more difficult to compress compared to gas. Okay? Alright, so liquid more difficult to compress. Why? Because very little empty space. Okay, due to the particles closely packed together. Okay, that is the reason why. Okay, next we are going to look at the next properties, which is viscosity. So what is viscosity? So viscosity is the ability for the liquid to move, to flow against the gravity lah. So the flow against the gravity, jatuh macam tu kan, flow of the liquid. So kalau the greater the viscosity of the liquid, maksudnya kelikatan dia tu lagi kuat. Okay, viscosity ni bahasa Melayu dia kelikatan. So, the higher the viscosity, so maksudnya more slowly it flows. Okay? So lagi tinggi dia punya viscosity, lagi lambatlah dia flow. Okay, because viscosity ni kelikatan kan, so lagi likat, lagi slow dia move, dia flow. Okay. So apa dia punya factors that affect the viscosity of the liquid? The factors that affect the viscosity of the liquid ada dua. First one is the size of molecule. So the bigger the size, the higher the molar mass. So bila lagi berat, lagi high dia punya viscosity. So lagi slow dia flow. Okay, the second one is the strength of intermolecular forces. So the stronger the intermolecular forces between the molecule, the higher the viscosity. Okay, these are the two factors that affect the viscosity of the liquid. Okay, second we are going to look at this last properties of the liquid, which is surface tension. So surface tension ni is the amount of energy required to stretch the surface of a liquid by a unit area. So liquid dia ada surface dia kan kat sini. Okay, so dia liquid. Okay, liquid ada molecules dia, betul. Okay, this is the Oh, tapi dia tak rapat sangat. So, liquid dia arrange macam ni lah contohnya. Jarak-jarak. Okay. So, liquid has the surface molecule, right? So, what is surface tension is? Surface tension is the what we call it, the forces that is exerted on the molecules of the liquid at the surface punya part. Okay, sebab apa? This one they stretch from here, atas tak ada, sorry. Bawah. Between the molecules dekat sideways and downwards. Okay, sideways dengan downward. So, liquid molecule ni, dia experience attractive forces in all direction. Okay, in all direction by their neighboring molecule. Okay, kalau yang molekul bawah-bawah ni, dia experience from the upwards, downwards, sideways punya intermolecular forces. Okay, however, molecules are at the surface, they are pulled downwards and stretched sideways. Tengok dia pull downwards and stretch sideways. So, bila awak kena pull downwards, stretch sideways, you punya tension makin lama makin tegang. So, that's why the stronger the intermolecular forces between the molecule, the higher the surface tension. Okay, so that's why kalau you tengok the water strider can walk on the water because of water has surface tension. Dia ada ketegangan dekat situ yang menyebabkan surface tu tegang dan serangga boleh jalan atas air. Okay. Okay, so maksudnya surface tu tighten to form an elastic film. Okay, kat sini kita cakap surface tighten to form okay, so this is for surface tension. Okay, now we are going to continue with the second part of the chapter, which is vaporization. We're going to look at the process involved in the liquid phase. So there are three processes that involve in liquid phase, which are vaporization process, condensation process, and boiling process. So we're going to look at the vaporization process first. So what is vaporization? So vaporization is the process in which molecules escape from liquid into gaseous state through a surface. So maksudnya liquid molecule escape from a liquid into gaseous state through a surface. Okay, so let's look at this flowchart mind map. So vaporization is a process which molecule escape from liquid to gaseous state, right? Okay, through the surface. So that means that the vaporization occurs on the liquid surface only, and it can occur at any temperature and at any pressure, as long as the liquid molecules at the surface, okay, remember at the surface, possess enough kinetic energy to overcome the forces of attraction between them. They can evaporate from liquid surface area to a gaseous state. Okay, so let's look at the process of vaporization based on the kinetic molecular theory. So based on kinetic molecular theory, the process is, so we know that liquid molecules are closely packed together but not rigidly, which means that they can move freely and collide with one another. Okay, and these liquid molecules, they each possess different magnitude of kinetic energy, which means that ada certain molecule they move slower, ada certain molecule they move faster. So each molecules they possess different magnitude of kinetic energy. Okay, so So when the molecule have sufficient kinetic energy, so they have sufficient kinetic energy, the kinetic energy is sufficient enough for them to overcome the attractive forces that bind them together. So the molecules will then loosen themselves and escape as a vapor. So that's why liquid to gas, they evaporate as a vapor. Wow. Okay, gaseous state. Okay, boleh faham So, Miss ulang sekali lagi. So, vaporization process ni is when the liquid molecules have enough kinetic energy to overcome the attractive forces that bind them together for them to lose themselves and escape from the liquid surface, from the liquid state into the vapor or gaseous state. Okay, boleh faham So, this vaporization process can occur only at the surface of the liquid, and they can occur at any temperature and at any pressure. Okay, so that is for the vaporization process. Okay, so let's look at the factors that affect the rate of vaporization. So there are 3 factors that influence the rate of vaporization. There are surface area, temperature, and intermolecular attractive forces. And we're going to look at these factors one by one. Okay, so let's look at the first factor, surface area. So, the larger the surface area, okay, the higher the chance for the liquid molecules to escape from the surface. Yelah, lagi lebar permukaan air tu, lagi banyaklah lagi liquid molecules on the surface kan. So, the higher the chance for the liquid molecule to escape from the surface. Okay, so that means that the higher rate of vaporization. Okay, now let's look at the second factors. So, the second factors is temperature. So, the higher the temperature, which means that you increase the temperature by heating up the liquid, so more molecule will possess higher kinetic energy. Okay, so when you increase the temperature of the liquid, you will increase the molecules that can have higher kinetic energy. So when these molecules have higher kinetic energy, means that more molecules will have enough energy to overcome the attractive forces that bind them together and escape from the liquid surface as vapor. Okay, when that happens, so the rate of vaporization increases. Okay, so the third factors is intermolecular attractive forces. So when the molecules have weaker intermolecular forces between them, so less energy is needed to overcome the attractive forces between molecules. So when there is less energy is required to overcome the forces, so the liquid molecule can escape from the liquid surface into a vapor easily lah kan. So that's why the rate of vaporization increases. So there are 3. So that are the 3 factors that influence the rate of vaporization. The first one is surface area, the second one is temperature, and the third one is intermolecular forces. So make sure you remember these 3 factors, okay? Okay. So now we are going to look at the second process that is happening in liquid phase, which is condensation. Okay, so kalau tadi evaporation from liquid phase into a gas phase, so condensation is the opposite process of vaporization. So condensation is a process in which gas is transformed back into liquid. Okay, so dia punya opposite process of the vaporization. So, process of condensation based on kinetic molecular theory. So, this is the process lah. So, some of the vapor molecule, okay. Tadi masa kita buat vaporization, liquid from the surface have escaped from the surface to form a vapor. Okay, so these vapor molecules, they have a kinetic energy, right? They gerak, right? So some of vapor molecules, they may lose their kinetic energy because they collide with each other during collision. So when some of these vapor molecules, they lose their kinetic energy, they do not have enough energy to remain as the vapor molecule. So what they will do, they will reach back to the surface of the liquid and became trapped by the attractive forces. So bila diorang dah jatuh atas permukaan liquid, akan ada attractive forces lah bind between them, right? So when they reach the surface of the liquid and trapped by the attractive forces, okay, some of them can overcome the attractive forces. But if they cannot overcome the attractive forces, this vapor molecule will then return back as a liquid molecule. So this is how the condensation process occurs based on the kinetic molecular theory. Okay? So now, so this condensation dia usually happens in a closed system. So contoh bila you jerang air, okay, no. When you put your water dekat contoh tengah-tengah cahaya matahari, you perasan tak ada wap air kat botol you, betul? So that one is the condensation process. Your water your water at the surface of the liquid has undergo evaporation process. Okay, but then since dekat closed closed container, some of the molecule dia tak ada enough energy to remain as vapor molecule, so they went back to liquid lah. So what kat tepi tu is where the vapor molecule turn back into a liquid state. Okay, the vapor. So that one is the condensation process. Okay. Alright. So now we are going to look at what is meant by vapor pressure. So vapor pressure ni is the pressure exerted by the vapor molecules in equilibrium with its liquid in a closed container. Maksudnya vapor dia ada pressure in equilibrium with liquid dalam closed container. So this vapor pressure akan ada bila dia dekat dalam closed system saja. Okay, so kita tengok apa maksud dynamic equilibrium. Okay, dynamic equilibrium is a state where the number of molecules in vapor remain constant in a closed container. Maksudnya apa? Maksudnya, kita tengok description dekat bawah ni. Maksudnya, the rate of the liquid molecule escape as vapor molecule is equal to the rate of the vapor molecule collide continuously and condense back into liquid molecule. So that's why the number of molecule in vapor remain constant. Sebab dia punya process of vaporization is the same as the rate of process of condensation. Dapat kat bawah ni. So rate of vaporization is equal to rate of condensation. Sebab itulah this what we call dynamic equilibrium. Okay? Maksudnya the number of vapor molecule remain constant at closed container. They at closed container only, okay? Liquid molecule escape as vapor pressure, and then liquid molecule escape as vapor molecule, and then vapor molecule they condense back into liquid molecule at the same rate. Okay, maksudnya kat situ this in a closed container ada dynamic equilibrium lah. Okay, alright. Okay, so now we are going to look at boiling. Okay, kita tengok apa maksud boiling. Okay, so boiling ni, in contrast with vaporization, boiling dia occurs at specific temperature and pressure. So dia ada specific temperature, maksudnya different molecule have different boiling point and they can boil at different pressure lah. Okay, and dia boleh berlaku bukan saja at surface of the liquid but also inner part of the liquid. Maksudnya the whole liquid, throughout the liquid. Okay, setiap particles, molecules dalam liquid tu akan undergo boiling process. Okay, bukan dekat surface je but dekat inner part of the liquid pun. Okay, remember that's the difference between vaporization process and boiling process. Okay, so there are two types of boiling point. The first one is the atmospheric, is the boiling point saja, and the second one is normal boiling point. So, what's the difference between boiling point and normal boiling point? So, boiling point is the temperature at which the vapor pressure of its liquid is equal to the external atmospheric pressure. Okay, remember temperature at which the vapor pressure of its liquid is equal to the external atmospheric pressure. So that is the definition of boiling point. So what is the definition of normal boiling point? So normal boiling point is the temperature at which the vapor pressure of its liquid is equal to the external pressure of 1 atm. Okay, mesti 1 atm. Pressure dia 1 atm baru dia panggil normal boiling point. Okay, nampak 1 atm je dia normal boiling point. Okay, kalau dia kata external atmospheric pressure, dia adalah boiling point sahaja. So that's the difference between boiling point dengan normal boiling point. Okay, remember Okay. Next, we are going to look at the last part of this chapter, which is the relationship between the intermolecular forces and vapor pressure, intermolecular forces and boiling point, and the vapor pressure and boiling point. Kita ada macam-macam relationship between them. So, diorang ni saling kait mengait antara satu sama lain. Okay, so let's look at the relationship between intermolecular forces dengan vapor pressure dulu. Okay, so kita ada strong intermolecular forces and kita ada weak intermolecular forces. So, when this liquid molecule have strong intermolecular forces, that means that more energy is required to overcome the strong intermolecular forces between the molecule. So, that means that molecule will be hard to escape to form a vapor molecule. Okay, so when the liquid molecule hard to escape to form a vapor molecule, so the vapor pressure is low. That means that the liquid is less volatile. They are less likely to escape to a vapor state. Okay? Because why? Because more energy is required sebab dia ada strong intermolecular forces. So the liquid is less volatile and has low vapor pressure. However, if the liquid has weak intermolecular forces, less energy is required to overcome the weak intermolecular forces between molecules. Means that the liquid molecule here, they can easily escape to form a vapor molecule. So, in this case, the liquid is said to be more volatile and has high vapor pressure. So, the liquid that has high vapor pressure and more volatile, they can easily escape from liquid to a vapor state. Okay? Alright. So, now, what's the relationship between the vapor pressure and the boiling point? So, when the liquid is less volatile and has low vapor pressure, more energy is required to overcome the intermolecular forces acting on them to vaporize and reach a vapor pressure that is equivalent to the atmospheric pressure. So, sebabkan diorang ni tak suka, diorang ni ada strong intermolecular forces between them, kan? So, diorang ni less volatile. Diorang tak suka sangat nak escape from liquid to vapor. So, maksudnya more energy is required to overcome the intermolecular forces for them to vaporize and reach a vapor pressure that is equivalent to the atmospheric pressure. Okay? So, that's why lagi less volatile, lagi high boiling point. When the liquid has low vapor pressure, it has high boiling point sebab more energy required. So, lagi banyaklah heat yang kena kan. So, makin lama, makin tinggilah boiling point dia. Okay, however, in contrast with the liquid that has high vapor pressure, more volatile, less energy is required sebab molecule ni diorang senang nak escape from liquid to vapor state, to gas state. Okay, so less energy is required to overcome the intermolecular forces and they are more readily to reach a vapor pressure that is equivalent to the atmospheric pressure. So, bila they are more readily to reach a vapor pressure that is equivalent to the atmospheric pressure, they have low boiling point. Tak perlu nak panaskan lama-lama, dia dah sampai dah dia punya boiling point kan. So, sebab tu dia ada low boiling point. So, remember that a more volatile liquid has low boiling point. The less volatile liquid has high boiling point. Okay, as a conclusion, when the liquid has stronger intermolecular forces, they have lower vapor pressure. So means that it is a less volatile liquid. So when they have low vapor pressure, they have high boiling point. However, when the liquid have weak intermolecular forces, they have high vapor pressure, which means that the liquid is more volatile. They can easily escape to form vapor. Okay, then when they have high vapor pressure, so the liquid has low boiling point. Okay, so that are the relationship of the intermolecular forces with vapor pressure and boiling point. Okay, so actually that is it for the chapter 5.2. We have finished chapter 5.2. And if you want to answer your tutorial question, so your tutorial question is really simple. It only asks you what I have explained to you in this video is the answer for your tutorial. Okay, look at this question. It asks you to describe the properties of liquid. This one you can find the answer on your lecture slide. Okay, PowerPoint. And then question number 2, it asks you based on kinetic molecular theory, explain vaporization and condensation process. I have already stated inside the slide and also in my notes, in this whiteboard note. Dah boleh settle jawapan. And then dia kata state the factors that affect the rate of vaporization of liquid. I have explained in this video. And then number 4, this will define terms of vapor pressure, boiling point and normal boiling point. I just explained just now. And then this will explain the relationship between intermolecular forces and vapor pressure and boiling point. I have also explained just now. So basically what you have learned just now is sufficient enough for you to answer the tutorial question by yourself. If you have problem with understanding this part of lecture, this part of tutorial, please inform me and ask me. Okay, and I will explain to you, okay? Back. Okay. So I think for the tutorial question, you have no problem to answer the question because the answer for the question are all inside the notes and my video. Okay, so for your attendance, please answer this quiz chapter 5.2. Wajib jawab. I take your attendance based on this. Okay, scan this QR code and answer only 5 questions only. Okay, 5 questions only for this chapter. You have to answer. Okay, for those who still not answer your quiz chapter 5.1, please do so. Only 15 people yang dah jawab quiz chapter 5.1. Okay, 8 more people need to answer 5.1. And please answer this quiz also because I will take your attendance based on this quiz. Okay, so that's all for today. I will end this video for this tutorial at this point. Okay, I hope that you will enjoy this video and will gain more understanding on this chapter. Alright, that's all. Bye. Assalamualaikum. See you in the next video. Bye-bye.